Science doesn't give you certainty, and that's exactly why it works. We like to believe that science is a machine for truth, something that can answer every question if we just look deep enough, measure carefully enough, think hard enough, and when it comes to the biggest question of all, does God exist? Many people turn to science expecting a final answer, a clear yes or a clear no. But here's the uncomfortable reality. Science was never designed to give you absolute certainty. It doesn't prove things in the way we often imagine. It tests, it questions, it updates, and it leaves room for doubt. So when we ask whether God is real, we may be asking something deeper without realizing it. Not just what the answer is, but whether science is even the right tool to find it. There is a question that has followed humanity for as long as we have been able to think. A question that appears in different forms across every culture, every civilization, every era. Who created all of this? Why does anything exist at all? Is there something beyond the universe? Something intentional, something watching, something we might call God. Long before science, long before telescopes and equations and particle accelerators, humans were already searching for answers. They looked at the sky and saw patterns. They felt fear and wonder at the same time. And from that mixture of curiosity and uncertainty, stories were born. These stories became beliefs, and those beliefs became religions, each offering its own explanation for the origin and meaning of existence. For thousands of years, these answers were not just ideas. They were foundations for how people lived their lives. They explained suffering. They justified hope. They gave structure to chaos. If something happened that could not be understood, it was often attributed to something beyond human comprehension, something divine. And for a very long time, that was enough. Not because the answers were proven, but because they filled the gap that uncertainty created. Humans do not like unanswered questions, especially when those questions touch something as deep as existence itself. Then something changed. Slowly at first, then faster and faster, humans began to develop a new way of understanding the world. Instead of asking what we should believe, they started asking what we can test. Instead of accepting explanations, they began to challenge them. This shift gave birth to science, and science did something extraordinary. It started to explain things that once seemed mysterious. Lightning was no longer a sign of divine anger, but a natural electrical phenomenon. The motion of the planets was no longer guided by unseen forces, but by predictable laws. Disease was no longer a punishment, but something caused by organisms too small to see. As science grew more powerful, something else happened. Confidence grew with it. If science could explain lightning, planets, and life itself, then maybe, just maybe, it could answer everything, including the biggest question of all: does God exist? And this is where the tension begins, because the question that once belonged entirely to philosophy and religion started to drift into the territory of science. People began to expect that the same method that could split the atom and map the cosmos should also be able to give a final answer about God. But hidden inside that expectation is a subtle assumption. It assumes that every meaningful question is a scientific question. It assumes that if something is real, then it must be measurable, observable, testable, and if it cannot be tested, then it must not be real. At first glance, that seems reasonable. Science has been incredibly successful using exactly that approach. But the deeper you think about it, the less obvious it becomes. Because not all questions behave the same way. Some questions can be answered by experiment, others cannot. And the question of God may belong to a category that does not fit neatly into the scientific method. This is why the question never goes away. Not because it is simple, but because it sits at the edge of what we can know. Every generation inherits it, and every generation tries to answer it using the best tools available at the time. In the past, those tools were stories and beliefs. Today, they include science, but the presence of a new tool does not automatically guarantee a final answer. Sometimes it just changes the way we ask the question, and that is where we find ourselves now. Standing between two powerful ways of understanding the world. On one side, the human need for meaning, for purpose, for something beyond randomness. On the other side, the scientific method, grounded in evidence, driven by doubt, and limited to what can be tested. The question of God sits right between them, refusing to fully belong to either side. And perhaps that is why it has never disappeared. Not because we are not smart enough to answer it, but because it may not be the kind of question that can be answered in the way we expect. When people think about science, they often imagine a system that produces facts, solid, unchanging truths about the world. It feels like science is a kind of ultimate authority, something that proves things once and for all. But that picture is not quite accurate. Science does not deal in absolute certainty, and it never really has. What it actually does is far more subtle, and in many ways, far more powerful. Science is a method, not a collection of final answers. It is a process built on observation, testing, and constant revision. It does not begin with truth. It begins with doubt. At the heart of science is a simple idea. Instead of asking what we want to believe, we ask what the evidence shows. We observe the world carefully. We form hypotheses to explain what we see. And then we test those hypotheses as rigorously as possible. If the idea survives repeated testing, it becomes stronger. If it fails, we discard it or modify it. This cycle never really ends. Even our most trusted theories are always open to challenge. That is not a weakness of science. It is exactly what makes it reliable over time. One of the most important concepts in science is uncertainty. In everyday language, uncertainty sounds like a flaw, something we should eliminate. But in science, uncertainty is built into the system. Every measurement has an error range. Every conclusion comes with a level of confidence, not a guarantee. When scientists say they are 99% sure about something, they are not being hesitant. They are being precise. They are telling you exactly how strong the evidence is and where its limits are. That honesty is what separates science from belief systems that claim certainty without evidence. Closely tied to uncertainty is doubt. Outside of science, doubt is often seen as something negative, a lack of conviction or confidence. But in science, doubt is essential. It is what prevents us from fooling ourselves. Every good scientist is trained to question their own results, to look for errors, to assume that something might be wrong until it has been tested again and again. This culture of skepticism creates a system where ideas are constantly challenged, not protected. And over time, only the strongest ideas survive. Another key concept is probability. Many of the conclusions we rely on in science are not absolute truths, but extremely high probabilities. For example, when we say that a certain medicine worked, What we really mean is that in controlled experiments, it consistently produces better outcomes with a very high degree of confidence. There is still a chance it might fail in some cases, but the probability of success is so high that we trust it. This way of thinking is very different from the way humans naturally want to think. We prefer clear answers, yes or no, true or false. Science rarely gives us that simplicity. This is why the statement that science proves things can be misleading. Science does not prove in the strict, absolute sense that mathematics does. In mathematics, you can derive conclusions that are logically certain within a defined system. In science, you are always dealing with the real world, which is messy, complex, and sometimes unpredictable. Instead of proof, science offers the best explanation available given the current evidence. And that explanation can always be refined or replaced if new evidence appears. This constant openness to revision is what allows science to progress. It is why our understanding of the universe has changed so dramatically over time. Ideas that once seemed certain have been replaced by better models, not because science failed, but because it succeeded in correcting itself. That is the real strength of the scientific method. It is not about being right from the beginning. It is about getting less wrong over time. When you understand science this way, something important becomes clear. Science is not designed to answer every possible question. It is designed to answer questions that can be tested against reality. Questions where evidence can be gathered, measured, and evaluated. It works best when there is something to observe, something to experiment on, something that can either support or contradict an idea. And when those conditions are not present, the power of science becomes more limited. This does not make science weak. In fact, it is the opposite. By clearly defining what it can and cannot do, science avoids making claims it cannot support. It stays grounded in evidence, even if that means admitting uncertainty. And that is why, despite not offering absolute certainty, science remains the most reliable tool we have for understanding the natural world. Humans have a deep and almost instinctive need for certainty. We want clear answers, stable ground, something we can hold on to without hesitation. When we ask a question, especially an important one, we are not just looking for information. We are looking for closure. We want to know that something is true, completely true, beyond doubt. This desire runs so deep that we often mistake confidence for truth and simplicity for accuracy. And this is where the illusion begins. In everyday life, certainty feels comfortable. If you believe something with absolute confidence, it removes anxiety. There is no need to question, no need to revisit, no need to consider alternatives. It gives you a sense of control in a world that is often unpredictable. This is why systems that offer absolute answers can feel so appealing. They do not just give you explanations, they give you stability. But the comfort of certainty can come at a cost. It can make us less willing to question, less open to new information, and more likely to ignore evidence that challenges what we already believe. Science moves in the opposite direction. Instead of offering certainty, it constantly reminds us of how much we do not know, and that can feel unsettling. When scientists present a result, they rarely say something is 100% true. They talk about confidence levels, error margins, and probabilities to someone outside of science. This can sound like weakness, as if scientists are unsure or indecisive. But in reality, it is a sign of intellectual honesty. Science does not pretend to eliminate uncertainty. It tries to measure it. The illusion of certainty often comes from misunderstanding what knowledge really is. We tend to think of knowledge as something fixed, a final answer that does not change. But in science, knowledge is more like a model, a representation of reality that works within certain limits. As we gather more data and improve our methods, these models evolve. They become more accurate, more predictive, but they are never completely final. There is always the possibility that new evidence could force us to revise what we thought we knew. History provides many examples of this. At one point, people were certain that the earth was the center of the universe. This idea was not just widely accepted, it was deeply believed. It felt obvious, supported by everyday observation. But as better measurements and new theories emerged, that certainty collapsed. The same thing happened with many other ideas. Concepts that once seemed unshakable were replaced, not because people suddenly became smarter, but because the process of questioning and testing revealed their limits. Each time, certainty gave way to a deeper, more accurate understanding. This pattern reveals something important. Certainty is often a temporary state, not a permanent one. It is what we feel when our current model of the world has not yet been challenged in a significant way. But the absence of challenge is not the same as the presence of truth. Just because something has not been proven wrong does not mean it is absolutely right. Science understands this, and that is why it avoids claiming certainty. Even when the evidence is extremely strong, there is also a psychological reason why we cling to certainty. Uncertainty creates discomfort. It forces us to live with unanswered questions, with incomplete information, with the possibility that we might be wrong. That is not easy. The human mind naturally tries to reduce this discomfort by simplifying the world into clear categories: true or false, real or not real, right or wrong. But reality does not always fit into those categories. Many of the most important questions exist in a space where the answers are not fully defined. When it comes to the question of God, this tension becomes even more intense. People do not just want an answer. They want a definitive one. Either God exists or does not exist. And they expect that with enough knowledge, we should be able to settle it. But this expectation carries the same illusion. It assumes that every meaningful question can be resolved with certainty, that every mystery has a final answer waiting to be discovered. Science challenges that assumption, not by dismissing the question, but by showing that certainty itself may not be the right standard. In this way, the illusion of certainty is not just about science. It is about how we think. It is about the difference between wanting answers and understanding the limits of what can be known. Science does not remove uncertainty. It teaches us how to live with it without deceiving ourselves. And that shift from seeking absolute certainty to accepting measured understanding may be one of the most important changes in how we approach the biggest questions we have. At this point, it becomes important to recognize something that is easy to overlook. Not every question we can ask is a scientific question. This might sound strange at first, especially in a world where science has been so successful at explaining so much. But the power of science comes from the way it works, and that also defines its limits. Science is not a universal tool for all kinds of questions. It is a very specific method designed for a specific type of problem. To understand this, think about how science operates at its core. It relies on observation, measurement, and testing. A scientific question is one that can, at least in principle, be connected to evidence. It leads to predictions that can be checked, experiments that can be repeated, and results that can be compared. If an idea cannot be tested in some way, science has no clear path to evaluate it. This does not mean the idea is false. It simply means it falls outside the reach of the method. Simple examples make this clearer. You can use a scale to measure weight with high precision, but you cannot use that same scale to measure beauty or meaning. You can use a thermometer to measure temperature, but not to determine whether a piece of music is moving or not. These are not failures of the tools. They are mismatches between the tool and the question. Each tool has a domain where it works, and outside of that domain, its usefulness disappears. Science works in a similar way. It is incredibly powerful when dealing with the physical world, things that can be observed, quantified, and tested. It can tell you how stars form, how chemicals react, how organisms evolve, and how particles behave at the smallest scales. But when a question moves away from what can be measured and into what might be inherently untestable, science begins to lose its grip, not because it is weak, but because it is being asked to operate outside its design. This is where confusion often arises. People take the success of science in one domain and assume it applies everywhere. If science can explain so much, then it should be able to explain everything. And if it cannot explain something, then that thing must not be real. But this reasoning quietly assumes that all real things must be accessible to measurement and testing. That assumption itself is not something science proves. It is something we bring into the discussion. The question of God sits directly in this tension. When someone asks, "Does God exist?" it sounds like a straightforward question, something that should have a clear answer. But the moment you try to treat it as a scientific question, complications appear. What would count as evidence? What kind of experiment could confirm or disprove such a claim? What observations would clearly distinguish a universe with God from a universe without one? These are not trivial details. They are essential to whether the question can even be approached scientifically. If the concept of God is defined in a way that interacts with the physical world in measurable ways, then in principle, science could look for those effects. But if God is defined as something beyond space and time, beyond matter and energy, beyond anything that can be observed or tested, then science has no direct access to it. In that case, the question remains meaningful to many people, but it is no longer a scientific question in the strict sense. This does not mean the question is unimportant or invalid. It simply means that we may need different kinds of thinking to approach it. Philosophy, for example, deals with questions about existence, meaning, and knowledge itself. It asks what kinds of explanations are possible, what counts as evidence, and what we can reasonably claim to know. These are not questions that can be settled by experiments alone. They require careful reasoning, clarity of definitions, and an understanding of the limits of our methods. Recognizing that not all questions are scientific is not a step backward. It is actually a sign of maturity in how we think. It prevents us from forcing every problem into a framework where it does not belong. It allows us to appreciate science for what it truly is, an incredibly powerful way of understanding the natural world, without expecting it to resolve every mystery we encounter. And when we return to the question of God with this perspective, something changes. The question itself does not disappear. but the way we approach it becomes more precise. Instead of demanding a scientific answer to something that may not be scientifically testable, we begin to ask a deeper question. What kind of question is this? And what kind of tools are appropriate for exploring it? That shift from rushing to an answer to carefully examining the nature of the question is where real understanding begins. When the question is asked, does God exist? It sounds simple, almost binary, like a switch that can be turned on or off. But the moment you look closer, the simplicity begins to dissolve. The real problem is not just the answer. It is the definition. What exactly do we mean by God? Without a clear and shared definition, the question itself becomes unstable. Different people can use the same word while pointing to completely different ideas. And without realizing it, they end up talking past each other. For some, God is understood as a being that directly interacts with the physical world, answering prayers, influencing events, performing miracles. In this version, God is not just abstract, but active, present within the fabric of reality in ways that might, at least in principle, leave observable traces. If this is the definition, then the question begins to approach something science can engage with. You could ask what evidence would be expected if such a being existed. You could look for patterns that cannot be explained by known natural processes. You could try to distinguish between coincidence and intervention. The question becomes difficult, but not completely disconnected from the scientific method. But for others, God is defined very differently, not as a being within the universe, but as something beyond it, not subject to space or time, not made of matter or energy, not bound by physical laws. In this view, God is not something that can be detected, measured, or observed in the usual sense. God becomes a foundational reality, something that exists outside the system that science studies. And once you define God in this way, the situation changes completely. Science, which depends on observation and testing, no longer has direct access to the subject. There are no experiments you can run on something defined as beyond all possible measurement. This is where many debates break down. Two people can argue about whether God exists, each presenting reasons and counter-arguments. But if they are working with different definitions, the discussion never truly connects. One might be thinking about a God that leaves evidence in the world, while the other is thinking about a God that, by definition, cannot be captured by evidence. They may use the same word, but they are asking different questions. And when questions are different at their core, no amount of argument will resolve the disagreement. This problem is not unique to the concept of God. In many areas of thought, unclear definitions lead to confusion and endless debate. But with God, the issue is amplified because the concept is so broad, so deeply tied to culture, philosophy, and personal belief. It carries emotional weight as well as intellectual complexity. That makes it even more important to slow down and ask what exactly is being claimed before trying to evaluate it from a scientific perspective. Clarity of definition is essential. Before you can test a hypothesis, you need to know what the hypothesis actually says. You need to know what would count as supporting evidence and what would count as evidence against it. If a claim is structured in such a way that no possible observation could challenge it, then science has no way to assess it. Again, this does not automatically mean the claim is false. It means it sits outside the framework that science uses to distinguish between competing explanations. This leads to an important insight. The difficulty in answering whether God exists is not just about lack of evidence. It is about the flexibility of the concept itself. The definition can shift depending on the context, becoming more concrete or more abstract as needed. In some cases, it is defined in a way that invites testing. In others, it is defined in a way that avoids it entirely. And as the definition shifts, so does the type of question we are asking. So before we even ask whether science can answer the question, we have to ask a more basic one. What version of God are we talking about? Is it something that interacts with the observable universe, or something that exists beyond it? Is it a hypothesis about how the world works, or a philosophical idea about why anything exists at all? Each version leads to a different kind of discussion, and each requires a different kind of reasoning. In this sense, the question does not fail because it is too big, but because it is too vague. Without a clear definition, it cannot be cleanly examined. And until that definition is made precise, the search for an answer will continue to drift. Not because the answer is impossible, but because the question itself has not yet been fully formed. One of the most common mistakes people make when thinking about big questions is confusing two ideas that sound similar but are fundamentally different: the absence of evidence and the evidence of absence. At first, they seem almost identical. If we cannot find evidence for something, does that not mean it probably is not there? But in careful reasoning, especially in science, these two are not the same. And understanding the difference changes how we approach questions like the existence of God. When we say there is no evidence for something, we are making a statement about what we have observed so far. We have looked, we have tested, and we have not found anything that clearly supports the claim. But this does not automatically mean the thing does not exist. It may simply mean we have not looked in the right way, or that our tools are not sensitive enough, or that the evidence is harder to detect than we expected. History is full of examples where something was real long before we had the ability to observe it. Bacteria existed long before microscopes. Planets beyond our solar system existed long before we had the instruments to detect them. In these cases, there was once no evidence, but that did not mean those things were absent. On the other hand, evidence of absence is a much stronger claim. It happens when we have a clear expectation that if something existed, it would produce observable effects. And yet, after careful and repeated searching, those effects are not found. In this situation, the lack of evidence begins to carry weight. It does not just reflect our ignorance. It starts to suggest that the thing in question may not be there, at least not in the form we expected. For example, if someone claims there is a large object in an empty room, something that should be easily visible, and we look carefully and see nothing, the absence of evidence becomes meaningful. It is not just that we have not found it, it is that we would expect to find it if it were real. The key difference lies in expectation. If a claim implies detectable consequences, then failing to detect those consequences can count against the claim. But if a claim is defined in a way that avoids any testable consequences, then the situation changes. There is no clear expectation of what we should observe, and therefore no straightforward way to interpret the lack of evidence. The absence of evidence remains just that, with an absence without strong implications either way. When applied to the question of God, this distinction becomes critical. If God is defined as a being that actively interacts with the physical world in measurable ways, then we can begin to ask what evidence should exist. Should there be patterns in events that cannot be explained by natural laws? Should there be consistent, observable effects tied to specific claims? If such expectations are clear, then the absence of evidence in those areas can start to matter. It may not completely rule out the idea, but it can challenge certain versions of it. However, if God is defined as something beyond observation, beyond measurement, beyond any interaction that could be tested, then the entire framework shifts. In that case, there are no clear predictions, no expected signals, no experiments that could confirm or deny the claim. The absence of evidence does not move us closer to a conclusion, because there was never a defined expectation of evidence to begin with. The question remains open, not because we have strong support, but because we lack a method to evaluate it. This is where many discussions become confused. People move between these two situations without realizing it. At one moment, they talk about a version of God that interacts with the world, and at another moment, they shift to a version that cannot be tested at all. This makes it difficult to apply consistent reasoning. Evidence is demanded in one context and dismissed in another, and as a result, the conversation never settles. Understanding the difference between no evidence and evidence of no does not give us a final answer, but it sharpens the question. It forces us to be clear about what we expect to see if a claim is true, and what it would mean if we do not see it. It prevents us from jumping to conclusions too quickly, either by rejecting something simply because we have not found evidence, or by protecting a claim from scrutiny, by defining it in a way that avoids all possible tests. In the end, this distinction reflects a deeper principle of scientific thinking. It is not just about collecting evidence, but about understanding what the absence of evidence actually tells us. And in the case of God, that depends entirely on how the idea is defined, what consequences it implies, and whether those consequences fall within the reach of observation at all. After everything we have explored, the question is no longer just whether God exists, but something more subtle and more important. What can science actually say? And where does its reach end? Because the true power of science is not that it answers every question, but that it knows exactly how far it can go. And that clarity, that honesty about its own limits, is what makes it one of the most reliable ways of understanding the world. Science has achieved something extraordinary. It has taken a universe that once seemed mysterious and unpredictable and revealed patterns, laws, and structures that allow us to make sense of it, from the motion of planets to the behavior of atoms, from the origins of stars to the complexity of life. Science has built models that not only explain what we observe, but also predict what we have not yet seen. This predictive power is one of its greatest strengths. It shows that our understanding is not just descriptive, but deeply connected to how reality actually behaves. But even at its most successful, science does not claim perfection. Every model, no matter how accurate, comes with conditions and limits. It works within a certain range, under certain assumptions, with a certain level of precision. Outside of those boundaries, it may need to be adjusted or replaced. This is not a flaw. It is the very mechanism that allows science to improve by never claiming absolute certainty. Science remains open to correction, and that openness is what keeps it moving forward. This leads to an important realization. Science is incredibly powerful within its domain, but it is not universal in scope. It is designed to study the natural world, things that can be observed, measured, and tested. When a question fits within that framework, science can make remarkable progress. But when a question moves beyond it, the tools of science begin to lose their effectiveness. Not because the question is unimportant, but because it may require a different kind of approach. The question of God sits right at this boundary. If framed in a way that connects to observable reality, science can engage with certain aspects of it. It can examine claims about the physical world, test predictions, and evaluate evidence. But if the question is framed in a way that places God beyond all observation and measurement, then science reaches a limit. It cannot confirm or deny something that produces no testable consequences. And recognizing that limit is not a defeat for science. It is a demonstration of its integrity. There is a deeper lesson here about how we think. Science teaches us to separate what we know from what we do not know, and from what we cannot yet know. These are not the same categories. What we know is supported by strong, tested evidence. What we do not know is open, waiting for further investigation. And what we cannot yet know lies beyond our current methods and tools. Confusing these categories leads to overconfidence on one side and unnecessary dismissal on the other. Clarity requires us to keep them distinct. In a world where people often seek certainty, this approach can feel unsatisfying. It does not give a final answer to every question. It does not close every gap in our understanding. But what it offers instead is something more durable. It offers a way of thinking that resists self-deception. It encourages us to follow the evidence as far as it goes, and to stop when it runs out, without inventing conclusions to fill the silence when applied to the question of God. This means accepting a nuanced position. Science can inform parts of the discussion, especially where claims intersect with observable reality. It can challenge ideas that conflict with evidence. It can refine our understanding of the universe in ways that shape how we think about existence itself. But it may not deliver a final verdict on every possible definition of God. And that is not because science is incomplete in a simple sense, but because the question may extend beyond the kind of answers science is built to provide. In the end, the real power of science is not that it gives us certainty about everything. It is that it gives us a reliable way to navigate uncertainty. It shows us how to ask better questions, how to test our ideas, and how to change our minds when the evidence demands it. And perhaps most importantly, it teaches us to face the unknown without pretending that we already have the answer.